Welcome to Web Handling. My name is Dave Royce. Winders are one of the most dangerous of web forming and web handling machines. This is for many reasons, including automation, NIPS, and high man-machine interaction. In this clip, we review some case histories of serious or even fatal accidents in order to learn how to prevent them in the future. H.W. Heinrich and later Frank Bird were among the first to do large-scale studies of industrial accidents. They observed that there were plenty of warnings that there was, as they say, an accident waiting to happen. While fatalities were fortunately rare, injuries that had similar ingredients were not as rare. Near misses or getting lucky were even more common. Think of how many times you've seen someone have to suddenly brake or change lanes to avoid a highway accident. Perhaps you've had to do this yourself. Now think of how many times you've seen people passing on hills, crossing double yellow lines, and not stopping completely and looking both ways at an intersection. These and other at-risk behaviors are nearly an everyday occurrence on roads near you. It is this at-risk behavior that has been the focus of many safety programs for two good reasons. The first is that risky behavior is a very, very common precursor to many accidents. The second reason is also practical. That is, that any single plant would experience very few serious accidents, so that if you wait to learn from that one how to prevent that one, you will often or even always be too late to prevent a different one. Fortunately, or unfortunately for us here, is that there are two groups of people that see serious accidents much more frequently. They are lawyers and expert witness engineers. I have been involved in the study of dozens of serious injuries and aware of scores more. So in this talk, we will focus on the top of the safety triangle instead of the more usual focus on the bottom. Each slide here represents not a single accident, but rather many. Names have been removed to protect the guilty and the unfortunate. After we go through several common accident scenarios, we will draw a few conclusions and offer a few best practices and suggestions. The two-drum winder is ubiquitous in paper mills. Every one of the 2,000 paper machines in the world has at least one, if not two, of these machines. Paper mills have much history, since they operate 24/7, 360 days per year, and have done so for nearly 200 years. Unfortunately, this history is not all that great. The two-drum winder has killed more workers than any other machine in the paper mill. There are many reasons for this, including a high degree of man-machine interaction. Every few minutes, a set of rolls needs to be changed out. Automation, at least for a while, until 100% enclosed guarding evolved, actually made things even more risky. There are many pinch points. The work is exhausting and stressful. These are just some of the ingredients for a variety of accident types that have occurred on this machine. We will only single out one type on this video, but there are dozens of other distinct serious accident types on this one machine. The front drum splice is the single most deadly accident type on this machine. While the details may be different than your winder, Many principles are common with many winders in other industries. The first challenge is that the splice is performed within 2 feet of dangerous locations, that is, an ingoing moving nip. In this case, a crushingly heavy nip. Note that OSHA and codes may not have prevented these accidents because there is a loophole clause that states that new machines where there is no known way to service with guards in place need not require them during this service procedure. Think of the challenge of guarding an airplane propeller and you get a layman's picture of this loophole. Until about 10 years ago, we had no such invention in the marketplace. Yes, now we do, but it is not required by code on older machinery. Still, with or without this Splice nip guard device, there are some best practices that apply here and well outside of this particular machine. First, hands away, up, and clearly visible by the operator of the jog switch. Second, the dead man's jog switch is a 3-position foot switch with an e-stop on both ends. This means that any movement by the operator would stop the machine. This is also far better than pull cords for reasons that we will see shortly, but the short answer is that the time when you need that switch is the time where one or both of your hands will be occupied. Hence, the usually superior performance of foot switches or light curtains. Without being gruesome, we should plan for failure. That is why we have first responders. Many paper mills have winder extraction devices as well as practice procedures. A few have tried what might seem to be an obvious treatment, reversing the direction of the nip drive. Unfortunately, one mill tried this and made the motor turn the wrong way, still forward, and turned a crushed arm into a dead operator. When I was an aviation pilot, it was my responsibility to know if there was anyone in proximity of the prop when I started the engine. When I am whitewater kayaking, everyone is responsible for knowing where their buddy is and where the rest of the small group is at all times. Don't service the machine or do experiments on a machine except under lockout-tagout protocols. I personally know of a dozen serious accidents or fatalities for overlooking this single protocol on just one type of winder. Equipment should have a 10 to 15 second stroke time and brush guards unless fully and impenetrably fenced. Color coding of paint is a great way to alert people of hazards. While not universal, yellow could be a hazard area and orange could be something that moves. Perhaps you can add some of your own observation in the comment section below. Hot threading, by which I mean threading at some speed, is not only common, it is the mode. We do not know of any other way on web-making machines such as film extruders and paper machines. It is quite common on converting machines of all types, including almost every rewinder. Yet, interacting with a machine, even at thread speeds as slow as a walk, is quite risky. Paper machines are threaded, sometimes manually, at speeds exceeding 5,000 feet per minute. Let me take just a single case I worked on to represent the dozens of similar ones I am aware of. This is the hot threading of a film extrusion line. This is done every time the line goes down on the dozen extruders in this plant and the 1,000 film extruders elsewhere. The day of this accident was a perfect storm. The film was a bit thicker. The film was a bit tackier. Please take heed that a wrapped idler roller or a wrapped core is always an ingoing nip. Well, on this accident day, an experienced operator got his hand entrained into the first wrap being threaded on the core because the film was a bit tackier than before. While one hand was thus occupied, the other was frantically flailing, trying to reach a poorly placed e-stop cord. Very soon, within seconds, the operator was sucked into the winding spindle and was being wrapped up with film like a cocoon. His co-workers heard his film-muffled screams and scurried to find an e-stop. Since they had never practiced e-stops before, they couldn't remember where they were during that frenetic minute or two. So they eventually went to the master control panel, changed a few screens, and adjusted the running speed down to 0. Fortunately, they got the operator out before he was smothered. However, the victim did suffer permanent arm and shoulder disabilities. Let us stop a moment and collect ourselves after this traumatic event. Let us try to see if there are any near universal trends in this accident and the others we've discussed. Pause the tape and write down your thoughts. Time's up. Were they ignoring lockout-tagout protocols? Yes, while some of our accidents, particularly for service, did fall into those categories, most did not. Was it failure to follow a code or written procedure? Well, maybe in some cases. But I'd bet that many routine operations or service functions are not described in sufficient detail, if at all, or that compliance is not always checked when it was written up. If we look back at the case histories presented here, almost all happened at stop, jog, or thread speeds. This is also true of 1,000 other serious injuries in our collective web industries. The reason is that the standard threading speed, the speed you walk at, is about 1 foot per second. The first second of time is what it takes to recognize the unexpected event for what it is. The second second of time is to try and make some effective action, such as finding the e-stop and pressing it. The final second of time is for the machine inertia to come to a stop. This, my friends, is why thread speed is so dangerous. It is beguiling. It looks safer than, say, 1,000 or certainly 10,000 feet a minute. Yet, the results can be just as deadly at walk speed as they are at highway speeds, with anything but narrow webs and anything but fragile webs, which both limit the forces to merely injury rather than death. Just because the roll is wound and put away does not mean you are still safe. The dangers of forklift and truck docks and freight elevators are pretty well known and well taught, but still people are getting hurt. What is not as well discussed is the stacking of rolls in a warehouse, which have a great deal of potential energy due to the combination of weight and height. Several workers have been killed by both pyramid and vertical stacking of rolls. I know, because I've worked on them as an expert witness and have seen security videos of the falling rolls. There are many wonderful safety programs, far too many to cover here. What I would like to highlight is just a few of my favorites. These would of course include lockout-tagout training, as well as compliance with codes and best practices, such as enumerated by Clarence Clausen at this and other conferences. It includes painting of floors and equipment in a universal fashion to designate the type of hazard, and many others. In the next 2 slides, I will cover a few of my favorites that are not as well known. Take-Two is a program pioneered by DuPont. Those of you who know history will know that this company essentially started during the Civil War, making explosives. Needless to say, the accident rates at that time were notable. A century and a half later is now also notable, but in a much better way. That is, the lost time and serious injury in some of their plants, or many of their plants, is 0 or near 0. One way they did this is to recognize that some or many accidents, particularly those involving service in engineering and troubleshooting, involved a procedure that was odd and not described in detail in some safety manual. The prevention was quite simple. Everyone steps back and takes 2 minutes to discuss and think through procedures, possible hazards, and workarounds to those hazards. 2 minutes is not the target, it is the minimum. If 2 hours or 2 days is needed to thoroughly think it out, well, so be it. Also, what they and several other corporations have done is painted the floors orange, extending 3 feet beyond the machine. Stepping on the orange floor is only permitted under very clearly written up situations, such as threading by operators or service under lockout-tagout conditions. Compliance is strictly enforced, especially for contractors, where a single infraction is immediate dismissal and blacklisting of that individual from future entrance into the corporation. Another best practices that I've seen that I really appreciate as a contractor is to have safety training done online with a test and a sign-off so that it can be taken efficiently before showing up at the guard shack during rush hour. Gets the job done and saves everyone a ton of time. Last, let me share a program I learned as an airplane pilot. The I Am Safe program was initiated by the FAA, who studies every single airplane accident in excruciating detail. I know, because I crashed my experimental aircraft after 3 years of flying, including winning awards at air shows. You can find the accident description up on my YouTube channel. I saw firsthand how thorough the process was, even for an accident involving but a single-seat, single-engine light airplane. In any case, both the FAA and the NTSB have found that most accidents, almost all accidents, involve people making poor decisions. So they studied the human factors that put people at risk. While developed for aviation, this applies equally well to cars and other machinery such as you have in your plant. To show just how strict the FAA is, I will take up just one example item from this list. Alcohol. There are 3 rules here, and violation of any one will usually result in a permanent loss of your license with no appeal process. The first is the easiest. A blood alcohol content of no more than 0.04%, which is far lower than any U.S. state laws for automobiles. The second is stricter and is summarized as the 8 hours bottle to throttle rule. 1 drop of alcohol will prevent you from legally flying for most of a day. The final is the strictest yet, that even the tiniest headache the following day for having a bit too much is, well, too much, even if you satisfy the first 2 rules. Thank you so very much for allowing me to share some of my most unpleasant learnings in my 40 years experience in some 1,000 different plants. Please comment below if you have any other favorite safety practices or programs. Please like and share if you found anything interesting or useful here.